Okay, so we got that ceramic socket out of there. I stripped out the wiring that was going through there to make the connection to from the both points on this base. It's not at all unusual to find old lamps like this lacking in a ground wire, and it's nothing to be concerned about. But this is what we typically refer to as a two-pole system. So one pole is for our active wire. The other pole is for our neutral wire. Remember, our active wire is going to always be black unless it's going to a switch that is mounted in the wall. In that case, the active wire is always going to be a colored wire. Any color other than white, green, or black. So the wire that came out of there is what's typically referred to as lamp cord. This is a piece of 18 gauge wire with rubber insulation on it. And the wire, even old lamp cord like this, will typically have some kind of marker indication on that wire to let us know which is the active wire and which is the neutral wire. So we're going to have to get some replacement wire that's going to be the same size as this because it has to feed through existing holes in this that won't allow for a larger diameter wire. So I've got to source a little bit of lamp cord. And you can see that this was, even if I wasn't replacing it because it looked bad, I can tell that it is bad because you can see that the insulation is cracking off of that, the wire and exposing the stranded copper wire inside. So if that came in contact with some part of the lamp, that could result in a short circuit. Which, if an outlet's not properly grounded, could result in you getting electrocuted. So let's, since we're going to have to wait until I get this wire to move further forward with this project, and I'm also, as I mentioned before, there was a high probability that this ferrule is rusted in place, so I'm going to this cleaned up beautifully. I mean, it's absolutely gorgeous patina on this. But I am going to have to soak this in penetrating fluid like WD-40 overnight and see if that doesn't let me get in there and loosen that up a little bit. If that doesn't work, I can take off the WD-40 and apply some heat to it. And sometimes because metal expands when it gets hot, that might loosen it up enough that I can get the rest of these parts out of that lamp. But let's look a little bit more at get that closer look at some of the things that are on the table. So as I mentioned before, we have a combination of things that include 3 different examples of electrician's pliers, insulated screwdrivers that are made for working with and working around electricity. This particular screwdriver allows me to be able to hold on to a screw without a magnetic tip. So it gives me a really low profile screwdriver that can get into tight places. And the way that it holds onto that screw is that as you draw this back, these two spread, and as I push this in, they move in closer to each other, which causes them to push out, which allows you to be able to hold on to a screw for locating it in a remote location or a location that's difficult to reach or access. We'll pull in for a super close look at these electrician's pliers so we can really read some of the information that's on those. I had introduced the idea of multimeters, which allow us to be able to measure things like voltage and amperage and something called continuity. So it's a very useful tool to have, but they're a little bit expensive. So if we're just checking for the presence of voltage, we can get away with using volt detectors. So volt detectors like this have 2 poles coming off of them. I have an extension cord. I want to make sure that I'm only holding the insulated part of these guys when I'm checking to see if I've got live electricity. So what I'm doing is I'm going to take the 2 poles, and when it comes to something like lamp work, it really doesn't matter which goes into which, but as I go in, you'll see that the light comes on, indicating that there is current flowing through that. Remember that on a 2-pole system, even if there's a ground on it, on a 2-pole system with or without a ground, you're still only going to have 1 active wire and 1 neutral wire. And when it comes to plugs, contemporary plugs, or the replacement plugs you buy at a hardware store, are going to have 1 large spade, which is the neutral, and 1 small spade, which is the active wire. And you'll see that when I go into the large opening, there's no indication of power at that point. And when I go into the small opening of my live wire, the tool lights up to indicate that there's power present. So these are useful tools for a quick check of whether or not there is active current being delivered to that device. I could also take those measurements off of posts like this that have wires coming into it. I talked about this idea of short-circuiting, which is when the flow of the current between an active wire and a neutral wire is interrupted, and the importance of a ground wire being present to be able to carry that electric current down to the earth rather than shunting that electricity through your body. A couple of safety devices that are used to intervene should there be excessive amounts of energy flowing through that wiring system is this device, which is called a circuit breaker, which if you go into the basement of your building, you'll find an electrical panel which has a series of these breakers in it that have a position for the active wire to be secured in place. And there's also a bar on the inside of that box that the neutral wire and a ground wire can be connected to. And basically the way these work is that when it's in the on position, if the amperage rating, in this case 15 amps, is exceeded and it senses that it's pulling too much energy through it, that could potentially cause that wire to melt, which could damage your electrical component and or result in a house fire, then it automatically tells a sensor to trip and stop that flow of current through the system. The circuit interrupters include not just circuit breakers, but an old school version of that, which is a fuse. And a fuse functions in a similar way, except that where a circuit breaker can be reset and turned back on, a fuse has to be replaced because it is consumed in the process of interrupting that current. And the way that works is that there's a filament that's bridging across between the active wire and the neutral, and if that current flowing across exceeds the rating, and again we have 15 amps, then it will actually melt that wire, which will no longer allow that current to flow through there. 2 other examples of fuses is this glass tube fuse, again with a wire running through it. This is used for direct current. And here's a contemporary version of that where the current is flowing through. If an excess amount of energy is flowing through, it'll melt that little bridge in between the two, or that fusible link, and it'll discontinue that flow. So this is what you're going to find in your fuse panel in your car. Another way that we interrupt the flow of current is to have a switch in the path of that active wire. So a switch is nothing more than a device that either opens and bridges the connection between those two poles. The hot leg comes in, hot leg comes out. So this breaks or interrupts it. This completes the circuit. A button like this that's used for a doorbell or an announcer of some kind does exactly the same thing. When it's in an upright position, the bridge is open, and when you push down, the bridge closes and allows that current to flow through. So because switches are only functioning with a live wire, it's one pole in and one pole out. But when it comes to outlets, I talked about how we have one pole, which is our live wire, and one pole, which is our neutral. These are color-coded so that a brass screw or a yellow-colored screw most typically denotes the live wire side, which corresponds to the smaller leg, and a silver-colored screw on the other side denotes the neutral side. So with a two-pole or two-wire system, when those two wires go into an outlet, my live wire is connected to one side and my neutral wire is connected to the other side. And we also have a screw lug that our ground wire is connected to, which would then be attached to something conductive like the metal box that an outlet like this is mounted into. So these metal boxes have names like 4x4s. This is a square 4x4 with a square cover for a duplex outlet and a rheostat control. These are generically referred to as handy boxes. They're engineered to hold one duplex one duplex outlet like this, or a switch could also be mounted onto a handy box like this. And you also have these octagonal boxes, which allow you to be able to use them as what's called a junction box, which allows us to bring wire in from one end, connect those wires together, and have wire out the other side. And what else do we have? At some point we may go through a tutorial of all of the connectors that are used for transitioning from what's called a knockout, which is the hole on the side, and this connector that allows us to be able to securely hold our insulated wire and plug in place. What else do we have on our table here? Signs of me being a hoarder. Usually if a tool's broken and it can't be repaired and the cord's in good shape, I'll usually just cut that cord off and stow it away and save myself the cost of having to go out and buy another one. And here you can see we've got our black is our active wire, white is our neutral wire, green is our ground wire, and our spade to your right, active, our spade to your left, neutral, and our ground wire.